Let's get started with DataStax Enterprise installation. But for that, we need to first prepare our servers. We'll install CentOS. So we will go to CentOS.org. We need to get the CentOS operating system. So we are here on the CentOS.org. We'll go to the CentOS Linux option. You can see here CentOS 8 and CentOS 7. There are two releases available right now. We are going to use CentOS 7. So let me click on this tab here and select the operating system suitable for your environment. I'm going with the x86 64-bit. Once we get here, CentOS.org is listing all the mirrors available for download. I'm going to randomly pick one mirror. You can download the ISO file from here, which is the disk image for CentOS 7.9.2009. This was released in November 2020, so this is pretty new operating system wise. What I have done is I have already downloaded this file, which contains the entire operating system in one ISO file. Okay, so let's get started with operating system installation on our server. I've started the server with CentOS 7.9 ISO file. I will continue with language English. Okay, so I'll scroll down and select the security policy first. So we don't have to do anything here. I'll just click on done. Next option is kdump. We'll leave it enabled. Next option I'll modify is the network and host name. So here you're going to configure all your network ports and everything. Now, first thing I would like to do, I would like to set my host name. Host name is, I'm going with HZD1, that is Horizon Zero Dawn, Oracle by example.com. And I will click on apply. Then the second thing we'll do, or the next thing we'll do, this is the first Ethernet port we have. We'll just switch it on. And you can see it automatically acquired IP address, but I'm going to configure this port or Ethernet port basically. I will switch to IPv4 settings and I will assign a static IP. So I'll select manual option, add, and I will specify the IP address. 192.168.1.166 and gateway is 192.168.1.1. Okay, and then I will specify the DNS server as 192.168.1.1. Now let's switch to IPv6 settings. And I would select ignore. Because I'm not using IPv6, I'm just ignoring the option. Say save. And you can see here now IP address 192.168.1.166 has been acquired for this particular network adapter. Now we'll click on the second network adapter and we'll just switch it on. I'm going to click on configure. Only thing I want to do is go to IPv6 and specify the option to ignore. I don't need IPv6 on this machine, so I'm just ignoring the IPv6. Here you can see it already connected to the network and it acquired IP address. So we are done with the hostname setting and the Ethernet ports configuration. I will say done. Next we'll go to installation destination. I have 2 hard drives attached to this server. We will install Linux operating system on the smaller disk. So we'll select this disk and I will specify that I will configure the partition. We'll click on done. We will click on create partitions automatically. And in the review screen, we will adjust some of these settings. We'll start with home. We'll remove the home mount point. Boot mount point, if you can see, this is 1 GB and I will leave it as is. We'll select swap. We will increase the swap mount point to 8 GB. We'll click on root mount point. We will increase the root mount point to remaining disk space. So we'll review the mount points. We have assigned 8 GB for our swap mount point. We have assigned 1 GB for our boot mount point. We have assigned 71 GB for the root mount point. We are done with partitioning. CentOS is confirming if we want to do all these changes. I'm going to accept changes. Next step is software selection. On this server, I'm going to install minimal CentOS so it can run efficiently with operating system consuming very little memory. I just clicked on minimal install and nothing else. I will say done. Installation source is local media, meaning I have inserted the CentOS disk or the ISO file. So that is what it is using to install the operating system. If at all we need to modify the language required for this operating system or keyboard, we can go to these options. I will skip these options and go to date and time. Here you can see my server is in the New York time zone, and which is okay for me. I will make sure the network time is on, meaning network time protocol, or on this server it will be Crony. Server will be in sync with the time using the network time protocol. I will click on done. At this point, we have already selected all the required options, so we can start installing the operating system. We'll click on begin installation. And you can see the installation has started. While it is installing, we can go and set a root password. So we are actually specifying the password for the root user on this server. I'm using a simple password. That's why you can see the password is weak. I'm going to click on done. It is complaining the password is too weak, and I have to click on the done button again if I want to still continue with the weak password. I will click on done. And we are back to looking at the installation screen. At this point, if at all we want to create the secondary user, there is an option here called user creation. Using this option, we can create other extra users on this operating system, on this server. We'll wait for a few minutes. So as you can see here, our operating system has been installed on our server. We have installed CentOS 7.9. It's asking for a reboot. So let's click on reboot to restart our server. As you can see here, our server is up and running again. So we can log in now. As you can see here, our server is up and running again. So we can log in now. I will log in as root user. First thing I want to check here is date and hostname. We can use hostname minus capital I command to check the IP address assigned to this box. We can use hostname minus small I to check if any other IP addresses are assigned to this box. Let us make sure we have connectivity to internet. So I'll clear my screen and I will ping google.com. As you can see here, our server is able to connect to internet. First thing we will do on this server, we need some tools to be installed. So let's install those tools. We will use yum install net tools, and I will specify -y flag so it can install the packages without asking us confirmation. As you can see here, NetTools package has been installed on this server. We will install some more packages so you can notice what I'm installing. We'll install wget. As you can see here, I'm installing OpenJDK. We will also install extra packages for Enterprise Linux. What you see on the screen is something called MobaXterm, which can be used for SSH connectivity. This is a simple SSH client, but very powerful. If you have not used MobaXterm before, I would seriously recommend you to try. It's a wonderful product and you'll fall in love with it. First thing we'll do is we'll create a folder for our connections. We'll call it as DSE. We will add connection to our server. We'll create a new session. This is a SSH session. Host IP is 192.168.1.166. I will be connecting to this server as root user. I can go to bookmark settings and modify if anything needs to be modified. I will just say OK. And as you can see, it has started to connect to my server. I will provide the password and we are able to connect to our server. As you can see here, I'm connected to Horizon Zero Dawn first server, HZD1, and I'm logged in as root user. So Linux operating system by default is protected with two things. One is called Security Enhanced Linux. So let's check the status of SE Linux. Using SE status command, as you can see here, current mode for Security Enhanced Linux is enforcing. We will disable this option. This is the configuration file for Security Enhanced Linux. We will modify this file. As you can see here, it says Security Enhanced Linux option is set to enforcing. I'm going to make a copy of that line, comment out the original setting, and change this value to disabled. I will save and close this file. Now, if you look at this SE status command output, current mode is enforcing, but the mode set in the configuration file is disabled. That means after we restart this server, security enhanced Linux will get disabled. Let us now verify if any firewalls are running on this machine. Using systemctl command, I'm checking the status for firewall D service. As you can see here, firewall D service is enabled and it is being actively enforcing firewalls. We will disable firewall D service on this box. Using this command, you can disable the firewall D service. As you can see now, firewall D service has been disabled, but it is still actively running. We will restart this server. As you see here, our server has restarted. Now, let us go ahead and verify if our security enhanced Linux has been disabled or not. As you can see here, security enhanced Linux is now disabled. Also, I have verified firewall D service and it has been disabled. As you can see here, this server has two Ethernet adapters. First one is called ENP0S3. It is assigned an IP address of 192.168.1.166. The second adapter is ENP0S8. It has IPv6. And this is the adapter I use to connect this server to the internet. Now, these network adapter names can change with every restart. So we would like to have static names for these Ethernet adapters. Step 1 to make the Ethernet adapter names static is to edit a configuration file. We will edit this configuration file. We have to find a line which says grub cmd line Linux. This is the parameter. Go to the end of the line and we will add a parameter called net.ifnames equal to 0. We are done with changes to this file. We'll save it and close it. Next thing we need to do is to recompile this grub configuration using grub to make config command. We are done with the configuration changes. Let's go ahead and change our Ethernet adapter names now. We have to modify this file. As you can see here, this is an empty new file. We'll add 2 entries in this file. We will save and close this file. As you can see here, we have modified this file and added these 2 entries into the configuration file. And notice that we are now going to have 2 Ethernet adapters. One is called ETH0, second one is called ETH1. We'll go into this folder which contains all our network adapter settings files. These are the 2 configuration files related to our current network adapters. I have made a copy of network adapter configuration file for ENP0S3 and saved it as ETH0. I have also made a copy of network adapter configuration file ENP0S8 and saved it as ETH1. Let us modify the configuration file for ETH0. We will set the boot protocol to static. We'll specify the network adapter name to be ETH0. We will remove this entry which contains UUID. We'll change the device setting to ETH0. This is the static IP which will be assigned to the network adapter ETH0. All the other settings in this file are looking correct. So we'll save and close this file. Now we will modify our configuration file for the second network adapter ETH1. We will modify the network adapter name to be ETH1. We'll delete the entry which contains UUID. We will modify the device name to ETH1. We will modify on boot setting to yes. All other entries in this file look good. So we'll save this file and close it. We need to restart our server to take all the network settings into effect. As you can see here, our server has restarted. And also notice that our network adapter names have changed to ETH0 and ETH1. ETH0 is assigned an IP address 192.168.1.166. Let us look at our mount points. As you can see here, we have assigned about 71 gigabytes for our root mount point. As you can see here, we have a disk which is not initialized yet, which is called SDB. Let us create a new partition on this device SDB. We'll use this fdisk command to create the new partition on SDB. Now we have created a partition on the SDB. It is called SDB1. We can use lsblk command to figure out what mount points are existing already and what are their file systems. As you can see here, SDB1 does not contain any file system. So we have to create a new file system on SDB1. Using mkfs command, let's create XFS file system on SDB1. As you can see here, we have created XFS file system on SDB1. Now, let us edit fstab file to mount the SDB1 on the folder we created just now, apps opt Cassandra. As you can see here, I have modified fstab file and added an entry for SDB1 to be mounted on this folder. Let us now restart the server. As you can see here, our SDB1 is now mounted on apps opt Cassandra and it is of 100 gigs in size. As you can see here, this system has 4 gigs of memory allocated to it. And it also has swap enabled. Generally, for DataStax Enterprise, it is recommended to disable the swap. So now let's go ahead and disable the swap. As you can see here, swap is now 0 bytes. We have disabled the swap. So let us now modify fstab to comment out the swap mount point. As you can see here, I have commented out swap mount point as it is recommended by DataStax Enterprise. I will now restart my server. So we have successfully disabled the swap, and we can continue to the next step. We will add an operating system group which will be used for our Cassandra user. We'll add a new operating system user, Cassandra, and add it to the Cass group. We'll modify the Cassandra user and set up the home folder for it. We'll specify the password for Cassandra user. As you can see here, we have successfully created an operating system user for Cassandra. As you can see here, we have a mount point called apps opt Cassandra. This is the home folder for Cassandra user. But let us set all the required permissions properly on this mount point for Cassandra user. We have modified all the required permissions for the Cassandra user on mount point apps opt Cassandra. We have to set up some security limits for Cassandra user. We will modify this etc security limits.conf file. We will scroll down almost to the end, and just before the end of file, let's insert some entries. I will save and close this file and then explain these entries. As you can see here, we have added these entries for Cassandra user to specify the OS level resource limits. Let us now log in as Cassandra user and set up some bash profile settings. As you can see here, Cassandra user home folder is apps opt Cassandra. Let us create a bash profile for Cassandra user. Let's exit and come back into Cassandra user. Okay, let's talk about DataStax Enterprise. So first let's go to datastax.com and we'll scroll down to the end of the page and click on About Us. You can read all about the DataStax company. We'll scroll a little bit and find this wheel which is talking about the DataStax Enterprise. So DataStax is a company which takes the open source Cassandra and enhances it by adding other features to it. As you can see here, Apache Cassandra is the core of the DataStax Enterprise. It has integration with Apache Spark, and it is called as DataStax Enterprise Analytics. It has integration with Solar, so it is called DataStax Enterprise Search. It has visual administration tool called OpsCenter. It has integrated advanced security, advanced replication. There are several developer tools provided by DataStax. It also provides certified distribution and support. Basically, you can call them 24/7 to open up a support ticket. That also comes with the license. So DataStax Enterprise basically has graph integration, analytics or Spark integration, and also it comes with Solar integration. So in this session, we will set up a 3-node cluster using DataStax Enterprise software. Using MobaXterm, I will connect to all my 3 servers. As you can see here, I have 3 servers. They're called HZD1, HZD2, and HZD3. First thing we will do is we will set up passwordless SSH between these servers. Notice that I have logged in as Cassandra user on these 3 servers. First, let us generate a new SSH key for each server. Using SSH keygen command, I'm going to generate a new SSH key for each server. I'm just going to select all the default options. So I'll just hit on enter and then keep going. Now we have generated a new SSH key on each server. Using SSH copy ID command, I can copy SSH keys to the specified server. I'm going to use this method and copy the keys to all three servers. It's asking me if I would like to continue and trust the server. I will say yes. It's asking me for the password to connect to HZD1. I've completed copying the SSH key to HZD1 server, and now I'll proceed to copy the key to HZD2 server. I will also copy the SSH key to HZD3 server. Now we have completed copying the SSH keys to the three servers we have, and we should be able to do a passwordless SSH between these three servers. As you can see here, now without giving any password, I'm able to run SSH commands on the remote servers. As you can see here, I have verified connection between all three servers without password. So this is the passwordless SSH configuration. For DataStax Enterprise, we need to have Java pre-installed. This is one of the prerequisites. As you can see here, we already have OpenJDK 1.8 installed and set up on this server. For DataStax Enterprise, we also require to have Python. As you can see here, Python 2.7.5 is already pre-installed on this server. DataStax Enterprise requires a special package called libaio. As you can see here on this server, we already have libaio package installed. So for DataStax Enterprise, we need three things pre-installed on the server as prerequisites: Java, Python, and libaio package. We need to make sure these three things are available on all three servers. Now that we have verified all the prerequisites are there on the server, I will go to the multi-execution mode. We'll create a folder for software and we'll download the DataStax Enterprise software. So we came to datastax.com. Let's scroll all the way to the end of the page and find the tools and downloads option. We will click on the enterprise option here and we'll click on this drop down and select the latest version available. As you can see here, we are downloading the Tarball package. DataStax Enterprise Software is a paid software. Even for development purposes, we have to pay license fee to DataStax. So please know that this is not a freeware. You have to get the licenses and contract with DataStax company. I have selected the latest version available, which is 6.8.11, and I'm downloading a Tarball. I will click on this checkbox and agree to the DataStax Enterprise terms and conditions. Instead of clicking on download, I'm going to right click and copy the link location. I will switch back to our server and use wget command to download the package. So as you can see here, we have downloaded DataStax Enterprise 6.8.11 Tarball package. Let us now copy this software to the other servers. Okay, now that we have the software downloaded, let us continue to install and configure this software. We will first configure everything on one server and we will copy the config files to the other servers later on when we are ready. As you can see here, I have logged into HZD1 server as Cassandra user. I'm in the home folder for Cassandra user and home folder is /apps opt Cassandra. Using tar command, I'm going to extract the tarball package, what we have downloaded earlier. As you can see here, DSE software has been extracted to this folder. First thing I will do is to create a soft link for the DSE folder. I'm also creating a soft link for the Cassandra configuration folder. It is always a good idea to remove the permissions for the configuration files for the others on the system. This is to protect the configuration files from unwanted viewing. We will repeat the same steps on the other servers. For DataStax Enterprise, we need to create these folders. Saved caches folder is used to save cache files. Hints will be saved in this folder. DSE stores special information called metadata, and metadata will be stored in this folder. Commit logs will be stored in this folder. All the SS tables related to the database are stored in this folder. CDC is change data capture. All the CDC related files will be stored in this folder. Software logs will be stored in this folder. DataStax Enterprise search logs will be stored in this folder. Let us now create all these folders on our servers. As you can see here, I'm back on my first server and I'm logged in as Cassandra user. The first file we would like to edit is the configuration file for Cassandra. The main configuration file for Cassandra in DSE is cassandra.yaml. Cassandra.yaml file is very well commented, and you can read each comment to understand what these parameters do. YAML file is very sensitive in its format. You cannot have extra spaces, or if you add a tab, it will give errors. The first parameter we will modify is cluster name. I'm going to copy this parameter and comment out the original parameter. I will name this cluster as HZD cluster. Next parameter we will find is num tokens. It is recommended to set up num tokens as 8. Now we'll keep scrolling down and look at more parameters. As you can see here, we would like to set up the hints directory to the hints directory we have created earlier. We will scroll down and find more parameters to edit. As you can notice here, by default, DSE comes with an authenticator called DSE Authenticator. In DSE, authorizer is set to DSE Authorizer. Also notice that in DSE, role manager is DSE role manager. For data file directories, we will specify our own location for the data file directory. We will specify our custom location for metadata directory. As you can see here, CDC is by default disabled. CDC is change data capture. Even though CDC is disabled on our cluster, we would like to set up the CDC raw directory folder to our custom location. As you can see here, we can specify a policy for data disk failures. By default, when disk failure happens, it will just stop. Similarly, we have an option to set up a policy for commit disk failures. We will specify a custom folder for saved caches directory. As you can see here, this is the parameter for seeds provider. Make sure to add 1 or 2 seeds from each data center and make sure you never add all of your nodes as seeds. Read a little bit more on seeds. This is a very important concept. As you can see here, I have specified two nodes in my cluster as seed nodes. Note that seeds are nothing special. They are the regular nodes in the cluster. They do not act like master or they do not hold any extra responsibility. They're just regular nodes. If you are using solid state disks for your storage, then you can enable this parameter called disk optimization strategy as SSD. Notice that storage port is 7000 and SSL storage port is 7001. These are the default values. If you need to change them, just make sure those ports are not already in use. Notice these listen address and listen interface settings. I'm going to disable the listen address and enable the listen interface. And I'm going to bind my listen interface to ETH0 network adapter. What this particular setting does is instead of binding the listen address to the IP address, it is binding it to the network adapter. So even if your IP address changes for the network adapter, Cassandra can still be up and running automatically, and it will bind to the network interface instead of connecting it to the IP address. Notice this parameter called start native transport is set to true. This is how all our clients connect to our cluster. Also notice native transport port is 9042. Notice there are two parameters called native transport address and native transport interface. Like we discussed about the listen interface and listen address, I'm going to disable the native transport address and I'm going to enable the native transport interface. And again, native transport interface, I'm binding it to the ETH0 network adapter. As you can see here, we have an option for enabling incremental backups. Right now it is disabled. I will not change the snapshot before compaction option. Let us change snapshot before dropping column to true. What this parameter does is, if at all you have to drop a column from the table, it will create a snapshot before dropping the column from the table. Auto snapshot is already set to true. I'm not going to change that. Zero copy streaming is by default enabled. Make sure to read about zero copy streaming. There are certain versions of DataStax Enterprise has bugs with zero copy streaming. Finally, we reach to a section where we will specify our snitch. We will be using gossiping property file snitch. As you can see here, endpoint snitch is set to DSE simple snitch by default. I'm going to make a copy of this parameter, comment this parameter out, and change the value to gossiping property file snitch. Let's scroll and look at some more options. This is the server encryption option. I'm not going to modify anything right now. This is the option for client encryption. I'm not going to modify anything right now. DataStax Enterprise has a beautiful feature called Node Sync. Here is the parameter which controls the bandwidth allocated for the node sync. As you can see here, backup service is by default disabled. Now that we have modified all the required parameters in Cassandra YAML file, I'm going to save and close this file. Since we are using gossiping property file snitch, we need to modify Cassandra rack DSE properties to set up our data center and rack details. As you can see here, I have set up my data center as East DC, and the rack this node belongs to is in rack 01. I'm going to save and close this file. Next, we will modify the Cassandra n.sh. We'll scroll down a little bit until end of the comments, we will insert few lines here. As you can notice, I have added a parameter called Cassandra heap dump directory and specified a location where it can write the Java heap dumps if at all JVM crashes. I've also included a location for Tomcat logs. We'll save this file and close it. In DataStax Enterprise, if we have to set up any specific options for JVM, then we have to modify a configuration file which is in conf folder, and the file name is called jvm-server options. Most likely we don't have to change anything in this file. Notice that heap settings can be modified here. If you need to increase the amount of RAM allocated for JVM, you can increase these two parameters, XMS and XMX. By default, it will auto calculate how much to allocate for JVM. I have not modified anything in this file, so I will just close it. Next, we will modify DSE environment shell file. We'll scroll down a little bit and add an entry for Cassandra log directory. This indicates where all the log files will be stored. We'll save and close this file. We will modify the bash profile. As you can see here, I have included DSE current/bin folder to my path. I will now copy all the config files to the other two nodes. We will copy the DSE env shell file also to the other nodes. We'll also copy the bash profile file to the other nodes. Remember that Cassandra RAG-DC properties file is very specific per node. You might have to edit this file on each node according to your environment. I will exit from the SSH session and re-log in. Now that we have finished all the settings required for DataStax Enterprise software, let's verify if we are able to see DSE command in our path. As you can see here, we are using DSE 6811 on this server. Now that we have completed all the settings required for the DSE, let's go ahead and start DataStax Enterprise Cassandra. Using DSE, we have to pass a parameter called Cassandra to start DataStax Enterprise with Cassandra only option. After a few minutes, looks like our DSE is up. We can verify if our DataStax Enterprise is up or not using node tool command. As you can see here, we have one data center called East DC. In this data center, we have one node which is handling 8 tokens. Now that we have our one node up in this cluster, let's go ahead and start DSE on the second node. After a few minutes, let's go ahead and verify if our node joined the cluster. As you can see here, now we have 2 nodes in our cluster. Let's go ahead and start DSE on the third node. Now, after some time, looks like our DSE startup has been completed on the third node. As you can see here, now we have built a 3-node DataStax enterprise cluster. All the nodes in this cluster are up and running. Now we can verify the version of DataStax Enterprise we are running by using DSE-v command. We can alternatively use node tool version command. And as you notice here, we are running DSE 6.8.11. We can use node tool status command to verify the health of the cluster. We can also use DSE tool status command. Node tool status command and DSE tool status command output almost look same, with little bit of enhanced output in DSE tool status command. Now let us check how to shut down DSE. We have to use DSE Cassandra stop command. Now we have successfully shut down DSE on this node. We'll go to another node and we'll verify the node tool status. As you can see here, this node is down. As you can see here, we are running DataStax Enterprise 6.8.11. And as you can see here, we have our 3-node DataStax Enterprise cluster. All nodes are up and running. Let us talk about log files. As you can see here, we are in apps opt Cassandra logs directory. All the log files related to DataStax Enterprise are located here in this folder. This is the system log file. This is the debug log file. This is the audit log file, which is stored under audit folder. Right now, by default, auditing is disabled. Later in this session, we will enable auditing on DataStax Enterprise. By default, when we install and configure DataStax Enterprise, Authentication and authorizer are by default not enabled. Using SQL command, I will log into my DSE cluster. As you can see here, I'm connected to HZD cluster. I have established this connection on HZD1 server. The default port is 9042. So if you notice, I did not provide any username or password to connect to our DSE cluster. Let us now talk about enabling authentication in our DSE cluster. First thing I want you to notice, there are two key spaces called System Auth and DSE Security. These two key spaces by default are using simple strategy for replication, and replication factor is set to 1. Before enabling authentication in our DSE cluster, we have to first change the replication settings for these two key spaces. Using SQL SH, I have logged into my DSE cluster. As you can see here, using alter keyspace command, I have modified the system auth keyspace to use network topology strategy as replication strategy. And also, I have increased the replication factor to 2 in East Data Center. Also notice that I have changed the replication strategy and replication factor settings for DSE security keyspace. It is suggested to have replication factor for these two key spaces set to at least quorum of nodes. I have 3 nodes, so keeping replication factor of 2 is perfectly okay for this cluster. We will now exit from SQL shell. For authentication and authorization, DataStax Enterprise supports 2 methods. First one is called role-based access control. For more granular control, we can also enable row-level access control. In this session, we will just use role-based access control and not enable row-level access control. As you can see here, By default, our Cassandra YAML file contains these entries. Authenticator is set to DataStax DSE Authenticator. Authorizer is set to DSE Authorizer. Role Manager is set to DSE Role Manager. There is one extra parameter called Internode Authenticator, which is disabled right now. We don't need to change any parameters in Cassandra YAML file for enabling authentication and authorizer in our DSE cluster. To enable authentication and authorization in our DSE cluster, we have to modify dse.yaml file. dse.yaml file is also well commented. You can read all the comments to understand what we have to do with the parameter settings. I will scroll down a little bit and find the authentication options section. By default, all the parameters under this section are commented out. I will find a blank line right after the authentication options section and insert new values in here. As you can see here, under authentication options, I have set enabled equal to true. Default authentication scheme is internal. We don't have any other schemes. Scheme permissions are not required, so this parameter is set to false. Allow digest with Kerberos is also set to false. When users log in with the plain text, and that is without SSL, whether we should be writing a warning message or we should just allow them, depending on that, this parameter is set. Right now, when users log in with plain text without SSL, it will allow the users to log in and there is no warning message written into the log file. Transitional mode need to be disabled. We'll scroll down a little bit and find the role management options section. As you can see here, all the parameters under role management options section is by default commented out. I will find the empty line after role management options section and insert some new values. If you notice, I have set the role management options mode to internal, and also I have enabled stats for these role management options. In DSE, authentication is possible via internal scheme, or you can enable LDAP integration, or you can also use Kerberos integration. Today, we are setting up internal scheme for authentication in our DSE cluster. Let us scroll down and look at authorization options. If you notice, all the parameters under authorization options section are by default commented out. I will find the empty line right after the authorization options section and insert some new values. As you can see here, under authorization options, I have set enabled equal to true. Transitional mode can be disabled. Allow row level security is what we were talking about earlier. We can enable row level access control, and I have set allow row level security equal to false. If you are setting up Kerberos integration or LDAP integration for authentication, you can read through this file and set up the related parameters. For basic security in DSE, using password authentication and authorization, these are the only parameters we need to change. So we can save this file and close it. Since we have changed the DSE YAML file, we have to copy this to the other nodes in our cluster. I have copied my DSE YAML file from my HZD1 server to HZD2 and HZD3 servers. Since we have completed modifying all the required parameters for our authentication and authorization, we have to restart DSE on each node. I'm stopping DSE using DSE cassandra-stop command. I will let the process sleep for 5 seconds. And then using DSE Cassandra command, I'm bringing up my DataStax Enterprise on this server. It took few minutes, but our DSE has restarted on this node. Let us restart DataStax Enterprise on our second server. Let us now restart DSE on our third server. We have successfully restarted all nodes in our DSE cluster. Let us now try to connect to our DSE cluster using SQL.sh. As you can see here, we are unable to connect to our DSE cluster without providing any username passwords. This is because we have enabled our authentication and authorization on our DSE cluster. Using these username and password options, I can connect to my DSE cluster using SQL.sh. Also notice the default username Cassandra with the password Cassandra is the default admin user. Now using username and password, I'm able to connect to my DataStax enterprise cluster. Using this select command, I can check what roles already exist on our cluster. As you can see here, Cassandra is the default admin role which exists on this cluster. First thing we will do on this cluster, we will create a new super user. Using create role command, I have created a new super user. As you can see here, Thor is a super user and anybody with Thor role can log in. Also notice that I'm using a very simple password for Thor role and it is not at all recommended to use simple passwords. I always create a secondary role which does not have super user privileges. Any users with this role can log into the system. As you can see here, I have granted select on all key spaces to the secondary role. I have also granted describe on all key spaces to this secondary role. Now, let us try to log into our DSE cluster using the newly created super user role. As you can see here, I was able to connect to my DSE cluster using the newly created super user role. It is recommended to disable the default Cassandra super user role. Using alter role command, I have removed the super user privileges granted to Cassandra role. Also notice that I have disabled logins using Cassandra role. Even though we disabled the default Cassandra role, it is recommended to further drop this role. So by mistake, nobody will ever have access to Cassandra role. Using drop role command, I have dropped the default Cassandra role. If you remember, during our configuration under DSE YAML for role management options, we have enabled to record statistics. This is the table which shows all the password changes and the role creation dates. Since this is a pretty new cluster we created, we don't have any application related key spaces on this cluster. With create key space command, I have created a new key space for sales. Let us now create few user roles which will be used for logging into the system and use this sales key space. Using create role command, I have created a new role called sales read write role. I have not granted super user privileges to this role. Users with this role can log into the system using this password. I have granted all permissions on sales key space to this role. Users who log in with this sales RW role can create, alter, drop any objects in sales key space. Users who log in with this role can also modify the data in sales key space. Using create role command, I have created another role called sales read-only user. I have granted only select privileges on sales key space to this role. So every time we want to connect to our DSE cluster using SQL SH, we have to provide certain things like host name and username and passwords. There is a small trick to hide all this in a config file. We can create this config file and store all the connection related configuration settings in this file. Let me save and close the file, and then I will explain how these parameters work. Since this file contains configuration settings to connect to our DSE cluster, including username passwords, it is always a good idea to protect it from other users. As you can see here, I have added these entries into my SQL SHRC file. Under authentication section, I have specified the username and passwords. Also notice that I'm using the secondary role which does not have super user privileges. Under connection section, I have specified which host it should be connecting to and the port it should be using to connect to our DSE cluster. Now that we have created a SQL SHRC file, we don't need to provide any parameters to connect to our DSE cluster on the command prompt. Notice that I'm now connected to my DSE cluster using low key role. We have successfully enabled authentication and authorization on our 3-node DSE cluster. So far, we have built a 3-node DataStax enterprise cluster, and we have enabled authentication and authorization on our cluster. So let's talk about the folder structure for DSE software. As you can see here, we have several folders under DSE current folder. All the commands and executable code is stored in bin folder. All the external libraries used by DSE are stored in lib folder. All the extra tools are stored in tools folder. Now let's talk about this resources folder. As you can see here, we are in resources folder, and this folder contains Cassandra folder. All the files related to Cassandra software are stored in this folder. All the DSE specific files are stored in this folder. All the graph related files are stored in this folder. All the log4j related files are stored in this folder. All the files related to solar software are stored in this folder. All the files related to Spark software are stored in this folder. If you notice here, we got 3 new nodes and the server names are Alloy1, Alloy2, and Alloy3. We are going to add these 3 new nodes into our existing DSE cluster and place them in a new data center. If you notice, I have extracted the DSE software and I have pre-created all the required folders and soft links. On Alloy1, let us start configuring it for DSE cluster. I'm going to copy all the configuration files from existing node. I will copy them from HZD1 server. Step 1, I'm copying the bash profile from HZD1 server to current server. Step 2, I will copy all the Cassandra config files from HZD1 server to current server. Step 3, I will copy dse.n.sh file from HZD1 server to current server. Finally, I will copy dse.yaml file from HZD1 server to current server. So these are the files I have copied from HZD1 server to the current server. Let's copy same thing on Alloy2 and Alloy3 servers. Notice that I'm back on my Alloy1 server. This is a new server and DSE is not running on this server. Let us now modify the Cassandra rack DSE properties file to specify our data center and rack details. Now that we are adding 3 new servers to the cluster and they belong to the data center West DC, I have specified data center equal to West DC, and these new servers will go into rack 2. Remember that data center does not need to be physical. It can be a virtual data center also. In case of DataStax Enterprise, you can run Apache Spark or Analytics in a dedicated data center. If you have 2 data centers, for example, we can run regular workloads like all the regular transactions in the first data center and only run analytics in the second data center. So in this case, we are getting 3 new servers, Alloy1, Alloy2, Alloy3. They will become part of the DSE cluster, and all these 3 new nodes will be placed in West data center. So all the other config files look good, and the only change required is for the Cassandra rack DSE properties file. So I will save this file and close it now. Notice that I'm now editing the Cassandra rack DSE properties file on Alloy2 server. I have changed my data center to SDC and also configured the rack. Now let's modify the Cassandra rack DSE properties file on Alloy3 server. On Alloy3 server also, I have modified the data center to SDC and accordingly changed the rack information. At this point, Alloy1 server is not part of our DSE cluster. So let's go ahead and start DSE on this node, which will allow this node to bootstrap and join the cluster. I'm starting the DSE process using DSE Cassandra command. This will start the bootstrap process and allow the Alloy1 server to join to the DSE cluster. After a few minutes, looks like our startup has complete. Now you can see we have 2 data centers. Data center East DC has 3 nodes. And LI1 is part of West DC, and we have only one node in West DC right now. So we have successfully completed the bootstrapping of LI1 and it joined the DSE cluster. Let's go ahead and start bootstrapping of LI2 so that it can join the DSE cluster. So after several minutes, our LI2 server has joined the cluster. Let's verify the status using Node tool. As you can see here, West DC now has 2 nodes. Let's go ahead and bootstrap the third node also to join to the DSE cluster. As you can see here, now we have 3 nodes in East Data Center and 3 nodes in West Data Center. We have successfully built a multi-data center cluster. As you can see here, we have built our cluster using DSE version 6.8.11. As you can see here, we have built a cluster with 2 data centers. In Data Center East DC, we have 3 nodes, and we have added 3 more nodes into West Data Center. Notice that I'm using Node tool command here. But DataStax Enterprise comes with another tool called DSE tool. DSE tool status command output looks similar to Node tool status command, but DSE tool status command has little bit more information in the output. Now that we have all nodes up and running, and we have added 3 new nodes which belong to the West Data Center, we need to adjust the replication factor settings. Using CQL-SH, I have connected to my DataStax Enterprise cluster. As you can see here, using alter keyspace command, I'm adjusting the replication factor settings for system auth keyspace. I want to keep 2 copies on each data center. Using alter keyspace command, I'm adjusting the replication factor settings for DSE security keyspace. I want to keep 2 copies on each data center. If you remember, I have created sales keyspace for our application earlier on this cluster. Using alter keyspace command, I'm changing the replication factor settings for sales keyspace. For this keyspace also, I want to keep 2 copies on each data center. Note that you can have different replication factor settings for each data center. Since we added a new data center, I have modified replication factor settings for 3 keyspaces: system_auth, DSE_security, and sales keyspace. As you can see here, in our cluster, we have 2 data centers. Each data center has 3 nodes. Notice that with the data center, it has a column called workload equal to Cassandra. What it indicates in DataStax Enterprise is, in a data center, if we are running Cassandra only, or we can have Cassandra plus Analytics, which is Cassandra plus Spark, or you can also have Cassandra, Spark, and Solar, or Cassandra and Spark. There are several combinations you can configure in your DataStax Enterprise. We want to have analytics running on West Data Center. That means we will enable Spark on the West Data Center nodes. To enable Spark, we need to create few folders which are required for Spark. DataStax Enterprise has a component called DSE which is DataStax Enterprise File System. All the data related to DSE will be stored in this folder. All the temporary files related to RDDs will be stored in this folder. When Spark is running, we will have Spark Master and Spark Workers, and all the data related to Spark Worker will be stored in this folder. Spark Master and Spark Worker logs will be stored in these folders. DataStax Enterprise in recent versions has an option called Always On SQL. All the log files related to Always On SQL will be stored in this folder. We need to create these folders on all the nodes where we want to run Spark. General thumb rule to enable Spark is you have to run Spark on all nodes in the data center. We will be setting these permissions for Spark data folder. We will be setting these permissions for Spark logs folder. As you can see here, I have logged into my first node on the West Data Center as Cassandra User. I will create all the folders required for Spark on this node. I have also set up permissions on each of these folders. Notice that I have logged into my second node on the West Data Center as Cassandra User. I will now create all the required folders for Spark. I have also modified all the required permissions on these new folders. I have now logged into my third node on the West Data Center, and I will now create all the required folders for Spark. I have also modified the permissions required for these newly created folders. Notice that I have logged back into my first node in West Data Center as Cassandra User. To enable Spark, we have to modify a few configuration files. We will start with modifying Spark env.sh file. Most of the parameters in this file are commented out. As you can see here, I have added few entries right after the DSE config version line. Spark worker directory indicates where the data for the worker will be stored. Spark executor directories indicates where the data will be stored for RDDs. These two settings indicate where the master and worker log files will be stored. This parameter indicates where our always on SQL related log files will be stored. I will now save this file and close it. To configure Spark, we need to also modify this dse.yaml file. If you remember, we modified the dse.yaml file earlier to set up our authentication and authorization settings. On this editor, I have enabled the line numbers. We need to search for a keyword called DSEFS underscore options in this file. As you can see here, on line number 756, I found my DSEFS options section. I will insert few settings related to DSEFS options in this location. Remember that YAML files are very sensitive. If you by mistake add an extra space or a tab, it will result in error. As you can see here, I have enabled DataStax Enterprise file system. I have specified this folder as work directory for DSEFS. For DSEFS, I have specified this directory as data directory, where it will store data files related to DSEFS. I will now save this file and close it. We will now copy this Spark no.sh file from the first node in West Data Center to the other nodes in the West Data Center. Using secure copy command, I have copied this Spark no.sh file from the first server to the other two nodes in the West Data Center. We will now copy this dse.yaml file to the other nodes in the West Data Center. Using secure copy command, I have copied my dse.yaml file from the first node in West Data Center to the remaining nodes in the West Data Center. Notice that I have logged into my first node in the West Data Center as Cassandra User. To start Cassandra along with analytics option, we have to first stop the Cassandra running on this node. Using this command, I will stop the Cassandra process which is already running on this node. As you can see here, we were able to stop our Cassandra which is running on this node. Regularly, when you want to start Cassandra in DataStax Enterprise, you will use this command called DSE Cassandra. But now we want to start this particular node along with Spark. So when we use -k flag along with DSE Cassandra command, it will start Cassandra as well as Spark on this node. Looks like the DSE services are now up on this node. Let us go ahead and verify using DSE tool command. As you can see here on the West DC, now we have a mixed workload. And if you notice, we also have the analytics master enabled. What does mixed workload indicate is few nodes on this data center are running only Cassandra and few nodes are running Cassandra along with Spark. In DataStax Enterprise, it is not suggested to run mixed workloads. If you want a data center to run Spark along with Cassandra, then you should start Cassandra along with Spark on all nodes on this data center. If you notice, now I have logged into my second node on the West Data Center as Cassandra user. I'm now going to stop the DSE Cassandra which is running on this node. I will sleep for 5 seconds and then I will start DSE Cassandra along with -k option for starting along with Spark. Looks like DSE services on the second node are now up. Notice that I have logged into my third node in the West Data Center as Cassandra user. I will now stop the DSE Cassandra on this node and then I will start DSE Cassandra along with Spark on this node. As you can see here, we have restarted all 3 nodes in our West Data Center. Now we have West Data Center running workload equal to analytics. Workload analytics indicate that we are running Cassandra along with Spark on all nodes in this data center. Our Spark master or analytics master has been elected, and this is the node which is serving as Spark master. Now that we have enabled DSE Analytics or Spark on our West Data Center, we have to change replication factor settings for some of these key spaces. Note that these key spaces will require a minimum 3 copies in the West Data Center. Also notice that Hive Metastore is written in double quotes and that is required. Using CQLSH, I have connected to my DSE cluster. I will now go ahead and change the replication factor settings for the key spaces related to DSE Analytics or Spark. I will now exit from CQL shell. We have successfully enabled Spark or Analytics workload on our West data center in our DSE cluster. Before I get started with Spark Shell or DSE Spark, I'm going to set up two environment variables for this session. As you can see here, I have set up these two environment variables, which will be used as credentials to connect to our DSE Cassandra. I'm going to start a Spark shell using DSE Spark command. As you can see here, our Spark shell has started. In our Cassandra database, we have a table called daily sales in the sales key space. Using this command, let's get the first record from the sales key space daily sales table from our Cassandra. As you can see here, we are using Spark to query our table, which is sitting in the Cassandra database. We can also run a count command using Spark on the Cassandra table. As you can see here, we have 5 rows in our Cassandra table. In this way, we can also write Spark SQL. Now I will quit from Spark Shell. DataStax Enterprise provides us with one more tool called Spark SQL. In this Spark shell, we can directly run our select statements or the SQL statements. I will now exit from this shell. So far, we have completed setting up a 6-node DSE cluster These 6 nodes are distributed into 2 data centers. We have 3 nodes in each data center. We have configured and enabled authentication and authorization on our cluster. We also configured and enabled Spark or DSE analytics on our West data center nodes. We use the DSE Spark and DSE Spark SQL shells to interact with the data stored in our Cassandra database. Now that we have configured our DSE cluster, let's now configure OpsCenter. Notice that I have logged into HZD3 server as Cassandra user, and I am in the software folder. Let's go to datastax.com and download the OpsCenter software. We will scroll down all the way to the end of the page. We'll click on this Tools and Downloads option. We'll click on the Tools option. And by default, the first option here is the OpsCenter. So if you see here, we are looking at DataStax Enterprise OpsCenter. OpsCenter is an easy to use visual management tool for monitoring our DataStax Enterprise cluster. I will select the latest version. I'm downloading a tarball. I will click on agree to the terms and conditions for downloading the software. Instead of clicking on this download button, I'm going to right click and copy the link. I'm back on my HZD3 server. Using wget command, I'm going to download the OpsCenter software. OpsCenter software contains 2 parts. OpsCenter has an agent which should be running on all nodes of our DSE cluster. OpsCenter itself will run only on one node in our DSE cluster. OpsCenter software contains both of this agent and the OpsCenter software. First thing I will do is to extract the OpsCenter software. As you can see here, OpsCenter software has been extracted to this folder. I will now create a soft link for the OpsCenter folder. As you can see here, OpsCenter Software was extracted to this folder, and I have created a soft link for this folder. As you can see here, this folder contains the OpsCenter agent. I have created a folder for OpsCenter agent. I will now copy all the OpsCenter agent related files into the OpsCenter agent folder. This is the folder structure for OpsCenter agent. Note that we will be running our OpsCenter on HZD3 server. So, step 1, we will configure our OpsCenter agent. As you can see here, I have added this stomp interface entry into the OpsCenter agent configuration file. Next step is to distribute this OpsCenter agent software to all our nodes in the DSE cluster. As you can see here, I have connected to all my servers using MobiXterm's powerful feature called multi-execution mode. I have created OpsCenter agent folder on all my servers, and I have navigated into this folder. Using secure copy command, recursively, I will copy all the files which are under OpsCenter agent folder on HZD3 server to the current servers. With this, we have completed copying the OpsCenter agent software to all the nodes. As you can see here, I have logged into HZD3 server as Cassandra user. Let us now start OpsCenter on this node using this command. After some time, we will be able to connect to our OpsCenter using the web browser. As you can see here, initially we have started our OpsCenter and we are able to connect to the OpsCenter using a web browser. As you know, we already have our DSE cluster, so we are not creating a new cluster. We will just select Manage Existing Cluster option. We will click on Get Started option. As you can see here, it is asking me to provide some of the IP addresses for our DSE cluster. I have provided two IP addresses from my DSE cluster. We have enabled native transport security on our cluster. So we have to click on this option here. I have provided the credentials to connect to our DSE cluster. I will click on Next. OpsCenter is trying to connect to the cluster. As you see here, it is talking about OpsCenter agents. I will select Install Agents Manually option. I will click on Close. At this time, it is a good idea to start our OpsCenter agents. As you can see here, I have connected to all my servers in the DSE cluster using MobiXterm's multi-execution mode. I have navigated to OpsCenter agent bin folder. In this folder, we will find a executable file called DataStax agent. I will now run DataStax agent to start OpsCenter DataStax agent. Notice that I have started my agent on all the nodes in the DSE cluster. After some time, DataStax OpsCenter will detect that all the agents are running. Using OpsCenter, we can monitor our health of the DSE cluster. Note that agents will take few minutes to send all the data to the OpsCenter. As you can see here, now all our OpsCenter DataStax agents are in healthy state. OpsCenter provides many interesting features which you can track your health of the cluster. You can see how much data is stored on the cluster. You can enable and disable node sync or repair options. You can enable backup service. You can monitor performance of your cluster. Using dashboard option on the OpsCenter, you can see the health of your cluster. There are several graphs provided for you to visualize your cluster and its health. Using data option in your OpsCenter, you can look at the key spaces existing in your Cassandra cluster. Now that we have our DataStax Enterprise cluster running, usually most of the time our developers want to use some products like DataStax Studio. So let's talk about DataStax Studio. Let's go to datastax.com website. I will scroll almost to the end of the page. I will click on Tools and Downloads. I will click on Tools. And notice there is a tool called DataStax Studio. DataStax Studio is a visual development tool for the developers to write queries and they can interact with our DataStax cluster. I'm going to select the latest version of DataStax Studio. I will download it for Windows version and I will agree to the terms and conditions provided for DataStax Studio. I can click on download. I have already downloaded this package onto my Windows machine. As you can see here, I have already downloaded DataStax Studio software onto my Windows box, and it is approximately 400 megabytes of size. I will first unzip this file. I will navigate to DataStax Studio folder. And I will navigate to bin folder. On Windows, I can run DataStax Studio using this server.bat file. This is a Windows batch file, so I will just double click on it. I'm going to say, I trust this software, please run it. As you can see here, DataStax Studio is starting up and it requires Java on your local box. DataStax Studio is a web-based tool. As you can see here, DataStax Studio has started and it is available on localhost port 9091. Let us now open DataStax Studio web page on our web browser. This is the DataStax Studio interface. I will first create a connection to my DataStax Enterprise cluster. I have provided a couple of IP addresses from my DSE cluster and the credentials required to connect to the cluster. I will click on Test My Connection. As you can see here, it got connected to the DSE cluster successfully. I will save this connection now. Going back to DataStax Studio, I can create a new notebook. I will just call it as My Notebook. As you can see here, we are connected to the DataStax Enterprise cluster. I can look at the schema by clicking this. I can select the sales key space or any other key space. I can expand and see all the columns in a specific table. I can type any select statements on this particular notebook. I can change the consistency to local quorum, and I can click on run this command. You can see the results in a tabular format. DataStax Studio is a great tool to interact with your DataStax Enterprise cluster. Every node in DataStax Enterprise cluster will record system log and debug log and several other logs. As you can see here on this node, all the logs are in this folder. All the generic system related messages are recorded in the system log file. Very detailed debug information is recorded in debug log file. As you can see here, DataStax Enterprise also created an audit log file. Audit logs are by default disabled. So let us go ahead and enable the audit logging. To enable audit logging in DataStax Enterprise, we need to modify this particular configuration file. If you remember, we have modified this file earlier for enabling authentication and authorization, and also for configuring DSE related options. We need to search for an entry called Audit Logging Options. As you can see here, audit logging is by default disabled. Remember that YAML file is very sensitive in formatting. If you by mistake add an extra space or a tab it will result in errors. As you can see here, under audit logging options section, I have set enabled equal to true. The logger we are going to use will be slog4j audit writer. We don't want to audit the queries and the DML statements. There are other parameters available to include some categories or include few key spaces, exclude few key spaces, include specific roles or exclude specific roles from the audit logging. I'm going to save this file and close it. We need to copy the DSE YAML config file to all other nodes in our cluster. We have to restart our DSE on each node. Using these commands, I'm going to stop the Cassandra running on this node and restart DSE Cassandra. DSE Cassandra on this node has been restarted. As you can see here, audit log now has few entries in it. Now we have successfully enabled audit logging on our DSE node. Remember to copy the DSE YAML config file, changes related to audit logging to all other nodes and bounce your Cassandra on all other nodes to enable audit logging. As you can see here, using CQL-SH, I'm connected to my DSE cluster. In sales key space, I have this table called lookup USA states. I have a requirement to run like queries on this table. As you can see here, we got an error. Like restriction is only supported on properly indexed columns. Note that in Cassandra, we cannot run like queries. DataStax Enterprise has a inbuilt product called DSE Search. DSE Search is built using Apache Solr and Apache Lucene. We can create DSE Search indexes on Cassandra tables. So let us check how to configure DSE Search. Note that I have logged into HZD1 server as Cassandra user. I'm going to enable DSE Search on all nodes of East Data Center. All the data related to DSE Search indexes will be stored in this folder. We will create this folder on all the other nodes in this data center. Note that I am back on my HZD1 server. This is the first node in East Data Center. We will modify DSE YAML file. We need to search for an entry called Solar Data Directory. As you can see here, I have added a new entry for Solar Data Directory. I will now save and close this file. Let us now copy the DSE YAML file to the other nodes in this data center. Using secure copy command, I have copied my DSE YAML file to the other two nodes in this data center. Using this command, I will first stop the DSE Cassandra, which is running on this node. I will let the process sleep for 5 seconds. And then I will start DSE Cassandra along with -s flag. -s is to start DSE Cassandra along with search. Notice that on East Data Center, workload has become mixed. As explained earlier, mixed workloads are not suggested in DSE. What does this mixed workload indicate here on East DC is, on one of our nodes, we have started DSE Cassandra along with search. On other nodes in the East Data Center, we are running only Cassandra. So let's go ahead and start DSE Cassandra along with search on the other two nodes in East Data Center. I will now stop DSE Cassandra and start it along with search on the second node. I will now stop DSE Cassandra and start DSE Cassandra along with search on the third node. After a few minutes, looks like our DSE Cassandra has started on all the nodes. As you can see here, now all nodes in East Data Center are running search. We have successfully enabled DSE Search on the East Data Center. Using CQL SH, I have logged into my DSE cluster. We can create search indexes using this syntax. If we need to drop the search indexes, we can use this syntax. Let us now create a search index on lookup USA states table in the sales key space. Notice that I'm creating index only on state name column, but we can include all the columns if required. It's always suggested to create a small index on the required columns instead of creating it on the full table. We have successfully created a search index. We can use this DSE tool command to figure out what is the status of the search index. Using this DSE tool command, let us verify the status of the search index. As you can see here, the search index exists and it is in a finished state. We can use this DSE tool command if at all we have to rebuild our search indexes. Using this DSE tool command, let us rebuild our search index. Note that there is no output on screen, but all the search index related messages are logged into the system log file. If you remember, we tried to run this like query before creating the search index and it failed. So let us run it again and see if our search index can be used for this query. As you can see here, now we are able to run like queries on our table using the DSE search indexes. This is my GitHub page where I have published several articles or code related to Apache Cassandra and DataStax Enterprise. There are very useful scripts under Apache Cassandra Administration Project. There are very useful monitoring scripts under this folder. You can also check out auto start scripts for DSE or Apache Cassandra under these folders. In this session, we started with building a DataStax Enterprise on 3 nodes in East Data Center. We have enabled authentication and authorization on our DSE cluster. We have added 3 more nodes in West Data Center, making it a multi-DC DSE cluster. We have also configured and enabled Spark or analytics workload on West Data Center. We have looked at OpsCenter, We have used DataStax Studio. We also checked on how to enable audit logging in our DataStax Enterprise cluster. Hope you enjoyed this journey of DataStax Enterprise with me. I really enjoyed making this video. Hope you have fun learning about it.